So yesterday we took notes over part one of the distance formula where we had two coordinate points and we graphed them to find the distance between them, and we used Pythagorean theorem to find that distance. Well, today is part two, and we're going to find the distance between the 2 points without graphing them this time. So that's the difference between part one and part two. In part one we graph, and in part two we don't. And there's a couple reasons why we want to do this without graphing. One of them is, honestly, every single time that you have to find the distance between 2 points, I'm not going to want to graph it. But also, sometimes you might have some really big coordinate points, like the point 90, 100. I'm not going to want to make a graph that goes all the way out there, and then I have to count all those spots. I'd rather be able to do it a different way. And so today we're going to figure out how to do it a different way without that graphing. When we did it yesterday, we created a triangle on our graph, and then we used Pythagorean theorem to find that missing side. We were always finding the hypotenuse. So, looking at our Pythagorean theorem, we were always finding C. So what you did was you would plug in your A and B and then square them, add them, and then square root it. Today, we're just going to make this look slightly different. Since we're solving for C, we want to write this as C equals something. That way we can just plug our answers into this and work down that problem. And we don't have to square root both sides of the equation at the end. So to get C squared to become C, I'm going to have to square root it, and the square and square root are going to cancel out. So whatever I do to one side, I have to do the other, and I'm going to square root the left side of this equation also. So C is equal to the square root of A squared plus B squared. Now note that this is not the same as the square root of A squared plus the square root of B squared. I can't break those up because those square root and squares would cancel out, and that would be C equals A plus B. And we know from the past couple days in class that this is not true. Okay, it's C squared equals A squared plus B squared. Okay, so don't do it that way. The plus sign makes the A squared and B squared stick together. So you can't separate them into different square roots. All right, so moving on, we'll come back to this in just a moment. Let's look at our first example. Our first example says to find the distance between the points 1, 2, and 4, 6. So I went ahead and graphed this. And so this is what you did yesterday. You would graph the 2 points, create a triangle, and then find the distances of those legs and solve the Pythagorean theorem. I want you to take a look at the relationship between the x's and the a value and the y's and the b value. So take a moment, pause this video, and look at the relationship between your x's, which is the first number in your parentheses, and your a, and then also look at your y's, which is always the second number, and your b. If you notice, your x's are 1 and 4, and your a is 3. So notice that 4 minus 1 is equal to 3. Your y's are 2 and 6, and your b is 4. So also notice that 6 minus 2 is equal to 4. What this is telling us is if you take the largest x, which in this case is 4, minus the smallest x, which is 1, it's going to equal your a value. So a is the largest x minus the smallest x. Same thing with your y's and your b. Your b, which is 4, is equal to your largest y minus your smallest y. Now we're going to use this information to actually find the distance between the points 1, 2, and 4, 6 without using the graph. So remember that we said the distance between those points is c, and c is equal to the square root of a squared plus b squared. And then we said that a is the largest x minus the smallest x. The largest x here is 4, so a is 4 minus 1. And 4 minus 1 is all a, so it's inside parentheses, and then I'm going to have that whole quantity squared. And then I'm going to add b, which is my largest y, minus my smallest y. My largest y is 6, minus my smallest y, which is 2. And once again, that's in parentheses, and I'm going to square it. And don't forget this big square root sign we have over the whole thing. That's going to follow us all the way down as we work out this problem. And we can't do anything with that until we get to the end, because that plus sign in there keeps the 4 minus 1 squared and 6 minus 2 squared together. So we can't do anything with that square root until we get all the way to the last step of this problem. So let's go ahead and work through this step by step, working inside the square root, doing our order of operations. So my first order of operations is parentheses. So inside my parentheses, I have 4 minus 1, which is 3. And then I'm going to copy down my squared, plus 6 minus 2, which is 4. And I'm going to copy down my squared. And I have that square root over the whole thing. Next, I have exponents. So I'm going to take 3 squared, which is 9, plus 4 squared, which is 16. Square root over the whole thing. Next, I have addition. So I'm going to take 16 plus 9, which is 25. And I have the square root over that. And the square root of 25 is 5. And remember, we're talking about distance on a graph. So our label is units. So the distance between those 2 points is 5 units. And that's my answer. Let's do another one. Let's do example 2. It says find the distance between the points 20, 91 and 40, 101. So I'm going to start by writing c equals the square root of a squared plus b squared. And then I'm going to plug in my numbers for a and b. A is my largest x minus my smallest x. So in this case, it's going to be 40 minus 20. And I'm going to square that. Plus b, which is my largest y minus my smallest y. So 101 minus 91. And I'm going to square that. And then I have a square root over that whole thing. Next, I'm going to work inside my parentheses. So I'm going to take 40 minus 20, which is 20, and I'm going to square that. And then 101 minus 91, which is 10, and I'm going to square that. And I have a square root over all of it. Now I'm going to do my exponents. So 20 squared is 400. If you don't know that off the top of your head, since you have 20 times 20, you can take 2 times 2, which is 4, and then you have 1 0 that you're squaring, so it becomes 2 zeros. And then 10 squared we know is 100. And I'm going to square root that whole thing. 400 plus 100 is 500, so I have the square root of 500. I'm not quite done yet because I need to simplify this. Okay, so I'm going to go over here to the side, and I'm going to simplify the square root of 500. This ends with 2 zeros, which means that 100 is a factor. Anytime that you have a number that ends with 2 zeros, that means 100 is always going to be a factor, so you can always use 100. 500 divided by 100 is 5. So my two factors are square root of 100 and square root of 5. And then as I simplify this, square root of 100 is 10 times the square root of 5. And now as I look at this, this is my most simplified answer. So this is going to be my answer for this problem. And I'm going to write this in units. For this set of homework, you only need to simplify your answers. You do not need to estimate on this one. So my answer for example 2 is 10 times the square root of 5 units. Go ahead and do example 3 on your own. Pause the video, work through it, and then unpause it and make sure that you did all your work correctly. I'm going to start this off, as usual, by writing c is equal to square root of a squared plus b squared. A is my largest x minus my smallest x. And so when I'm looking at these, I need to pay attention to the fact that they're both negative. So my largest number is actually negative 85. So I'm going to write negative 85 minus negative 100, and I'm going to square that. And then b is my largest y minus my smallest y. So that's 7 minus 5, and I'm going to square that and put my square root over this whole thing. Pay attention to your signs because I have minus a negative right here, so I need to add the inverse. So I have negative 85 plus 100, which equals a positive 15. And I'm going to square that, plus 7 minus 5, which equals 2, and I'm going to square that, and I have my square root over that whole thing. 15 squared is 225. 2 squared is 4. All of that under a square root. And now I'm going to add those two together to get square root of 229. Now this does not simplify, so my answer is square root of 229 units. Moving on to our fourth and final example. We have an airplane flying from Kansas City to Los Angeles, California. The latitude-longitude coordinates for Kansas City are 94, negative 39, and the coordinates for Los Angeles are 118, negative 34. Every coordinate is about 70 miles. How far will the airplane travel? So the first thing that we need to do here is find the distance between those two coordinates, and then we can find the actual distance in miles. So I need to take those two coordinates and use my distance formula that we've been working with, and then I'll convert that to miles. Okay, so I'm going to write the usual c is equal to the square root of a squared plus b squared. And now I'm going to write my numbers in here. Looking at my coordinates, I'll circle them so it's easier to see. First, I'm going to focus on my x's. My largest x is 118. And my smaller x is 94. And I'm going to square that. And now I'm going to look at my y's. My largest y is negative 34 minus negative 39. And I'm going to square that and square root the whole thing. 118 minus 94 is 24. So I have 24 squared. And then negative 34 minus negative 39, I'm going to add the inverse. Negative 34 plus 39 is 5. So I have 5 squared, and I'm going to square root the whole thing. 24 squared is 576, and 5 squared is 25. And I'm going to add those. 576 plus 25 is 601. And then I'm going to square root that whole thing. The distance in latitude, longitude coordinates from Kansas City to Los Angeles is the square root of 601 units. And this unit is the latitude, longitude unit. We know that every coordinate is about 70 miles. So that's saying for every 1 unit, it's 70 miles. So if we're converting from units to miles, our number is going to be going up, which means we're going to multiply. So I'm going to multiply square root of 601 by 70, and that will tell me how many miles. So I'm going to take 70 times the square root of 601, and that's my answer in miles. Now, if you want to know what this distance actually is, you can take the square root of 601 you can take the square root of 601 and then multiply that by 70. And that answer is 1,716. And I will say that right there is okay. 1,716 miles is the distance from Kansas City to Los Angeles. And that might not be totally exact because, like this says, every coordinate is about 70 miles. So it's not exactly 70. And latitude and longitude is slightly different because as you get farther away from the equator, the coordinates get a little farther apart. So it's not exactly 70 also for that reason. The problem on the homework is very, very similar to this problem. So you should be able to work it out now. And then there's one other application problem where you're given a graph, and so you have to find the points on the graph, figure out what those coordinates are, and then you can find the distance between them using those coordinates. I don't want you just counting on the graph.